Hi everyone, welcome back to Instrumentation Technician, where we make the complex world of instrumentation and control systems simple and easy to understand. In today's video, we're exploring one of the most asked questions in automation and process control. Backhand index pointing right. What's the real difference between SCADA and DCS? At first glance, both systems might look similar. They both collect data, control processes, and monitor plant operations. But once you understand how they're designed, how they work, and where they're used, the difference becomes crystal clear. By the end of this video, you'll know exactly. White heavy checkmark what SCADA is. White heavy checkmark what DCS is. White heavy checkmark how they're different. White heavy checkmark and which system suits your application best. So, let's dive right in. Brain Section 1, what is SCADA? SCADA stands for Supervisory Control and Data Acquisition. As the name suggests, it's a system designed for supervising and controlling equipment and processes that are spread out over large geographical areas. Imagine a power grid that stretches across cities, or a water distribution network that covers multiple districts. That's where SCADA comes in. SCADA systems collect real-time data from sensors, transmitters, and field instruments installed at remote sites. These devices send their data to PLCs, programmable logic controllers, or RTUs, remote terminal units. The PLCs and RTUs then communicate that information to a central control system, often called the SCADA server. At the control center, operators can view live process data on an HMI, human-machine interface, showing parameters like tank levels, flow rates, pressure, and alarms. They can also send commands back to the field, for example, opening a valve, starting a pump, or resetting an alarm, all without leaving the control room. SCADA is perfect for supervisory control, meaning it's used when the system doesn't need millisecond-level response but must monitor and manage equipment remotely. Some common industries using SCADA include electrical power transmission and distribution, water and wastewater management, oil and gas pipeline networks, railway and traffic control systems. The biggest strength of SCADA is its ability to handle geographically distributed sites. Even if your process units are in different cities, or even in different countries, a single SCADA system can monitor them all through secure communication networks. That's what makes SCADA ideal for centralized supervision over wide distances. Gear Section 2, what is DCS? Now, let's move to DCS, which stands for Distributed Control System. While SCADA focuses on remote and large-scale operations, DCS is built for complex, continuous control processes within a single industrial facility. Imagine a refinery, a chemical plant, or a power generation station, all located in one area. These processes need extremely precise and fast control. In a DCS setup, the plant is divided into different sections, called process areas or units. Each section has its own dedicated controller that handles the control logic for that part of the process. For example, one controller might manage a boiler, another handles the distillation column, and another regulates a reactor's temperature. All these controllers are connected through a high-speed communication network and report to the operator stations in the control room. The key point is, each controller in a DCS can operate independently, yet still share data with the central system. This distributed architecture increases reliability. If one controller fails, the others keep running, and the plant continues to operate safely. That's why DCS is preferred for real-time control, where every millisecond counts. Industries that rely heavily on DCS include oil refineries, chemical and petrochemical plants, thermal and nuclear power plants, food and pharmaceutical manufacturing. In these industries, maintaining stability, safety, and product quality is critical, and that's exactly what DCS delivers. High Voltage Section 3, core difference between SCADA and DCS. Let's summarize the major differences clearly. Feature: SCADA, DCS. Full form: Supervisory Control and Data Acquisition. Distributed Control System. Purpose: Remote monitoring and supervisory control. Continuous and complex process control. Geographical scope. Wide, multiple sites, even across cities. Local, within one plant or facility. Control execution. Done by PLCs/RTUs, not by SCADA software. Done by dedicated DCS controllers. Response time. Slower, seconds. Very fast, milliseconds. Data handling. Focuses on data acquisition, logging, and alarms. Focuses on closed-loop real-time control. Redundancy. High communication redundancy. High control redundancy. Example industries. Power grids, water networks, oil pipelines. Refineries, chemical plants, power plants. In short, backhand index pointing right SCADA equals centralized control, distributed sites. Backhand index pointing right DCS equals distributed control, centralized site. Globe showing Europe Africa Section 4, Real-world scenarios. Small blue diamond Scenario 1, Water Distribution Network, SCADA. Imagine you're managing a water supply system for an entire city. You have tanks, pumps, and valves scattered across dozens of locations. Instead of sending operators everywhere, you install sensors and RTUs at each site. These devices send real-time data, tank levels, pump status, pressure, to your central SCADA software. From your control room, you can see tank levels in all areas. Start or stop pumps remotely. Receive alarms if a tank level drops too low. And even generate daily reports automatically. That's SCADA, supervisory, remote, centralized, and perfect for distributed networks. Small blue diamond Scenario 2, Oil Refinery Plant, DCS. Now, picture an oil refinery. Hundreds of sensors and control loops maintain temperature, pressure, and flow in critical units. Here, you can't afford delays. If a pressure exceeds the limit, the system must react instantly, in milliseconds, not seconds. That's where DCS takes control. Each process area, like the distillation column or cracking unit, has its own controller that continuously adjusts valves, burners, and pumps. All these controllers are networked, allowing operators to monitor and optimize performance from a single screen. Even if one controller fails, others continue to operate, ensuring plant safety and reliability. That's DCS, distributed, fast, and built for continuous industrial control. Wrench Section 5, Communication and System Design. Both systems rely on robust communication networks, but the protocols differ. SCADA often uses Ethernet/IP, Modbus TCP, or DNP3, designed for long-distance communication and data polling. DCS systems typically use Profibus, Foundation Fieldbus, or proprietary high-speed protocols optimized for real-time control within a plant. In SCADA, data is often transmitted in intervals, for example, every few seconds, since processes don't require instant action. In DCS, communication is continuous and fast, because the system must maintain control loops in real time. Crystal Ball Section 6, Modern Trends. Today, the line between SCADA and DCS is blurring. With the rise of industrial IoT, IIoT, and cloud computing, modern plants often integrate both systems. You might find a DCS managing process control inside a plant, while SCADA oversees the same plant's data remotely for performance monitoring. New platforms even combine SCADA, DCS, and MES, manufacturing execution systems, into one intelligent ecosystem, offering cloud dashboards, predictive analytics, and AI-based fault detection. This evolution means that future automation systems will be hybrid, using the strengths of both SCADA and DCS for maximum efficiency. Direct Hit Section 7, Choosing between SCADA and DCS. If you're designing a system, here's how to choose. White heavy checkmark. Choose SCADA if you need to monitor geographically dispersed assets. Data logging, alarms, and remote control are the priorities. Real-time response isn't mission critical. White heavy checkmark. Choose DCS if Your process is continuous and located within one plant. You require instant control, redundancy, and reliability. You handle critical process variables like pressure, flow, or temperature. Remember, the goal isn't to decide which one is better, but which one fits your process. Section 8, Conclusion. So, to summarize, SCADA is all about monitoring and control across distance. DCS is all about real-time control within a single facility. Both systems are vital in industrial automation, they just serve different purposes. SCADA keeps you connected to faraway assets, while DCS keeps your local processes running safely and efficiently. In modern industries, you'll often see both working together, creating a smart, interconnected automation environment. If you found this explanation useful, don't forget to like, share, and subscribe to Instrumentation Technician for more real-world instrumentation content. Real-world instrumentation content. And if you're serious about building your instrumentation career, check out our upcoming training modules on industrial control systems, PLC logic, and instrument calibration. Links are in the description. Thanks for watching, see you in the next video.